James and I'm from Delta Electronics Singapore. Today I'm going to present on the microgrid solution. In 2016, Singapore signed the Paris Agreement alongside 30 other countries and pledged that by year 2030, we will reduce our emission intensity by 36% from the levels of year 2005. Since then, the government came up with long-term efforts and plan to achieve the commitment given during the Paris Agreement, such as the Singapore Energy Story, which was driven by the EMA in 2019. And early this year, they have also released the Singapore Green Plan 2030. This is to position ourselves achieving long-term net zero emissions aspiration. Now let's first take a look at the trend of the energy market and its transformation. On the left, you can see conventionally, energy was transmitted directly from a central power plant and distributed to various parts of the country. And now we are seeing more and more countries moving towards deregulation and liberalization of the energy industry. We also have decentralization of the power source and decarbonization with the increased use of the renewable energy. In addition to the power transmission, data are now also being collected so we can have real-time supply and demand management of the energy network. Next, to improve the efficiency and prevent losses through conversion, there's also a rise in the DC grid adoption. Instead of only being a consumer of energy in the past, now we do see a rise in prosumer or microgrid where there is an ability to sell excess energy from the alternative energy resources back to the main power grid. Finally, there's also a growing market on EV, which can also serve not only as a load, but also a form of virtual energy storage. Okay, what is microgrid? It is actually a smaller grid that connect and disconnect from a central grid or other microgrids to enable it to operate in both grid-connected or island mode. A microgrid is also a group of interconnected loads and distributed energy resources that acts as a single controllable entity. It is powered by renewable resources, batteries, and distributed generators. And finally, it is acting as a backup power available for during scenarios such as power outage, severe weather, or overloaded systems. Next, let's move on to see the benefits of microgrid. It provides efficient, low-cost, clean energy. It also improves the operation and stability of regional electric grid. It is a critical infrastructure that increases reliability and resilience. It reduces grid congestion and peak loads. It diversifies risks rather than concentrated risks. And comparing to a central power plant, it costs less to have total capital cost will be lesser to build. Right, this is an example whereby an EV charging station is being transformed into a microgrid. The roof of the station is installed with PV panels to harvest renewable energy. And we can also have bi-directional EV chargers so they not only charge the EVs, they also transfer power from EVs back to the energy infrastructure when required during emergency. We also have the ESS to regulate the energy and also to store excess energy harvested through the solar panels. It is also used as a power backup of the charging station. Finally, we have the Backend energy management system, which is the brain of the whole solution. It manages the multiple energy sources and optimizes the energy consumption of the complete solution. Now we move on to the microgrid energy storage system. Let's take a look at the applications of the energy storage. We separate the energy market into two main sectors, the utility and the commercial and industrial. In renewable power plants such as solar farms, the energy storage will be used for energy shifting, PV smoothing, and capacity firming. The ESS is also being used in distribution grid, which is mainly as a backup supply, and also for AFC. On the conventional power plant, The energy storage is used also as a backup to regulate the frequency and also for AGC purposes. Under the commercial and industrial sector, the energy storage is being used for energy management such as peak shaving, load shifting, PV self-consumption, cost optimization, power backup, and demand responses. It is also being used in the grid auxiliary services and in charging station and microgrid solution. We are now seeing more and more businesses committing to sustainability and green initiatives such as RE100 or measurement of ESG sustainability factor, and ESS can be deployed to help these companies meeting these initiatives. ESS is also used in supporting the grid for demand response, ancillary services, and in some countries to regulate the frequency of the grid. It can help to optimize energy costs through peak shaving and load shifting. It is used to store power for renewable integration, and also as a facility support. Energy storage can be used for emergency backup power and also to support the EV charging infrastructure. All right, these are the 4 key factors in the critical technology behind the energy storage system, which is the energy control and dispatch, energy management, power conversion, and battery management. This slide shows a typical architecture of the microgrid solution. Smart meters are being installed from different power sources, and information is being collected and sent to the controller, which will transfer them to the EMS. The software will then analyze the information and manage the complete infrastructure, such as when to isolate from the grid power and use battery as a power source, or when the energy harvested from the solar is more than the load. Excess power will be stored in the battery as backup, etc. All right, we move on to the Delta Grid energy management software. We have 3 different modules in Delta Grid family. We have the Delta Grid EM, which is the energy management. We have the Delta Grid modules for EV. And finally, we have Delta Grid for O&M, which is operation and management. In this slide, it shows you the real-time monitoring that provide you data such as energy harvested from the PV, or how much power we are generating from the power grid, and also the ESS, energy storage, how much output it has produced, and of course, what is the load. So it also acts as an energy management where you are able to have different control scenarios such as peak shaving, load shifting, charging limit control. It provides energy analysis and give you a very detailed reports for your reporting purposes. And it also have a module for the EV, which is providing your EV charging status, and also for you to monitor the charging sessions. The device management will provide you a list of devices in your network and what are their status. You are able to have real-time data collection and provide you to have an in-depth device management. And finally, for the operation and O&M services, it is able to give you the ability to have task management, such as issuing ticket when there's a job required, provide you the maintenance record, and help you to have tracking on the O&M progresses. Now let's take a look at a short clip on the explanation on the Delta Grid for EV management. Okay, this is a dashboard that provides you real-time information on the EV network. It can have the total power consumption, and you can group them to have group power consumption as well. Let's move on to the features of the Delta Grid energy management software. The Delta Grid is actually an energy management tool that provides real-time dynamic data display, and it also has graphical extension for management. It shows you the charge and discharge energy control, and it provides voltage, real and virtual power control. The software also allows you to perform different applications such as peak shaving or load shifting. It is central to the integration of PV, EV chargers, and energy storage solutions. Finally, this backend is hosted through cloud service and is cyber secure. What can Delta as a company offer to you? We have the complete one-stop integration capability of the solution. We manufacture our own EV chargers. We have our own PCS, UPS, battery systems, and PV systems. And they are all running on Delta controllers. So this will provide us an edge over the integration of the overall energy management software. This is our solution portfolio, and under the renewables and microgrid, we have PV inverters for a huge range of PV inverters. We have wind power converter. We have controllers for the solution. We have energy storage systems, a complete energy storage systems which consists of our own power conditioner systems, the controllers, and the battery systems. And we have our own backend energy management software. On the EV charging, we have a complete range of both AC and DC charger. We also have our V2X charger, which is a bi-directional charger, which will be one of the key components that you can find in microgrid solutions. We have tools to do simulation on the operation life of the solution, to optimal configurations to achieve highest efficiency, and most importantly, on financial investment factor, which is the ROI. We have huge range of power conditioning system from as small as 100 kilowatt to 4.1 megawatt. We have different battery storage system, which is being designed by ourselves, and we have different battery capacity range of 0.5C to 2C depending on your requirements. Of course, we have the control systems. As mentioned, the Delta Grid, which is the energy management systems, which I've explained earlier. We also work with local integration companies to provide the EPC, such as the integration tests, the transformers required on site. So we are also working with local partners to provide the complete EPC of the project, and we work with them on the components such as PDU, the transformers, and civil engineering work. With this, I would like to end my presentation on microgrid solution. My name is James. Should you have any questions or any interest on any of our Delta microgrid solution, please let me know. Thank you.